صباح الخير يا شباب، ازيكم؟ عاملين ايه وايه اخباركم اليومين دول في الوقت اللي انتوا بتقضوه في البيت؟ عموما النهارده ان شاء الله انا هبدأ معاكم شرح الشابترز اللي لسه ما خدناهاش لغايه دلوقتي. انا ببتدي معاكم دلوقتي تشابتر 19 احنا لسه ما اشتغلناش فيه. شابتر 19 اللي هو الالكترومagnetic فورسز. وعشان نبقى احنا عارفين ايه هي الالكترومagnetic فورسز بنبص نلاقي معانا هنا مكتوب الكترو ومagnetic وفورس، وده معناها ان انا عندي current وعندي magnetic field، والمagnetic field ده بيسبب موشن، يبقى في magnetic field والمagnetic field ده بيعمل موشن او فورس. يبقى دلوقتي عنوان الشابتر بتاعنا الكترومagnetic فورس، ان انا هستخدم current وهستخدم magnetic field، وان الكرنت بلس المagnetic field causes motion او causes force. في البداية خالص احنا عاوزين نقول one use of the electromagnets، واول جهاز موجود عندنا اللي هو زي ما انتم شايفين الريلاي سويتش. الريلاي سويتش ده زي ما انتم شايفين ده عبارة عن سيركت، والسيركت دي فيها سويتش، والسويتش متوصل بباتري، الباتري دي ماكسيمم 6 فولتس. يبقى انا عندي دلوقتي 6 فولتس. اللي يحصل لما اعمل سويتش اون للكي اللي متوصل بباتري ثرو ا كويل، يبقى الكويل هيبقى ماجنتايزد وهيبقى يديني magnetic field. المagnetic field ده affect مين؟ affect الايرون armature. الارمتشر ده اللي هو arm made of iron وبعدين اللي هو pivoted او اللي هو has a point او hinged at a point اللي هي هنا دي البيفوت بتاعتي. في البيفوت دي اللي بيحصل لما بيحصل attraction للارمتشر forward towards المagnet لانها because it is made of iron, it causes this part to push the second switch to be contact. طب وايه يعني لما يحصل contact؟ اهو بنقول connect to the second circuit. ايه second circuit؟ تبقى around 500 volts like which is used in factories. طب ايه الفايده بتاعت الكلام ده؟ يبقى we have a relay is an electrical switch with a low voltage، ادي اللو voltage اللي هو 6 volts that works another high voltage electric circuit. Okay, it is used in electronic circuit for safety. فبيستخدم for safety. Why? Because if you are an engineer and you have workers, these workers work with machines that work with 500 volts. So instead of pushing a button that has 500 volts and maybe someone has an electric shock due to any fault in the device, so when you switch on, you deal with a 6 volt low voltage circuit. So the low voltage circuit causes the armature to attract the second switch that works automatically. So no harmful effect, no injury, no any bad effect for the worker or for the engineer. طيب دلوقتي what is the drawing in the exam? The drawing in the exam comes in this form. What is this form? This form represents this part. What is this part? This part represents electromagnet. So this part, when you draw this part, it is an electromagnet. This electromagnet has two terminals. Okay, in front of it there is a switch. This switch is made of iron. This part is made of iron. So when the electric current, again we will surround it like that. But when we surround the electromagnet with the switch, it is called relay switch. So when the electromagnet becomes magnetized, it attracts the switch, which causes another circuit to be closed. This is 500 volt. This is one of the important applications for the electromagnet. This is one. So when switch 1 is on, lamp 1 glows. So when you switch this button here, so the current passes in the first circuit including or that includes the electromagnet so lamp 1 glows. When lamp 1 glows and the electromagnet is magnetized, so the switch is closed. So the second circuit is closed. So the lamp 2 glows. By the way, this is a question in your past paper. Okay? Now we will move to the other device, which is the normally read switch. What's normally read switch? Now we'll see. Normally open. What is normally open? As you see, I will draw it at the side. So there is a glass tube. Inside the glass tube, there are two pieces. One of them is made from iron, or both of them are made of iron. These are the two terminals of a circuit. This circuit is connected to a circle which has an M letter. M letter, it means electric motor, maybe use a high voltage. So when I draw here a power supply, it means that there is a high voltage, like the one before, which is 500 volts or any other volt. By the way, you have a coil. This coil surrounds the tube that is connected to a current which is low voltage, like the other one, which is the device we studied before. So it is what? It is a battery, like 6 volts, and you have a variable resistor and a switch. So when you press the switch, when the circuit is on, so current passes through the coil. This current causes a magnetic field around it. The magnetic field causes the two switches here to come closer to each other. These two switches come close to each other, so the circuit is closed for the electric motor and works. So look here, since it is without any current, it is open. The two terminals of the reed are far from each other. At the start, they are far from each other. So it is called normally open, NO. So it is normally open reed switch, okay? So it consists of a glass tube and the constituent is written here. So second one is normally closed. What is normally closed? As you see, the two terminals here are close to each other. But when it is put close to a magnet, so the magnet attracts this one to be pushed downward, so it prevents its connection. How does it work? Let's just imagine that we have a door, and this is the door of a home door, and here there is a magnet. This magnet is north and south. And what about this? It is the tube, and the tube has the two connections which are connected together through a bell, for example, or a buzz, okay, and a power supply. So when it is connected in this form, suppose that you have the door open. When the door is open, it means that the two terminals touching each other, so the bell rings or the buzz works. So when you close the door, what happens when you close the door? The magnet causes this two, let me show it to you to be clear here, okay, causes the two terminals to move far from each other, so the buzz stops. So what is the benefit of this one? The benefit of this one is an alarm for safety, but not for safety to not get injured, but it is for safety for homes. Anti-theft alarm, anti-theft alarm. Now, this is a question that comes in past paper. The past paper said that how does it work when there is a fire? As you studied before, that this component is called thermistor. What is thermistor? Thermistor is a device that when temperature is high, it is a special resistor. So it is not like the lamp, just for your knowledge. And as you know, it is opposite to the lamp. In case of the lamp looks like that. It's simple like that. When temperature increases, its resistance increases, so the voltage passes through it. It needs more voltage to pass through it, and usually I'm doing it like that, so current decreases. Current decreases, which means that no current or less current passes through the circuit. Look here. For the thermistor, when the temperature increases, its resistance decreases. Resistance decreases, it needs less voltage through it, which means that the current passes through it increases. When the current through this one decreases, the current decreases and the voltage decreases. So voltage decreases, correspondingly that voltage here increases, okay? Which means that current passes through the relay coil. Relay coil causes the switch to be closed and the ring or the buzz works. So it is a relay which is used in a fire alarm. So when temperature is high, you have to write this part. This is the answer of the question you have in your past papers. Resistance of the thermistor decreases, current increases and passes in the circuit. So the electromagnet magnetized and attract the iron switch, so current passes in the buzz and buzzes. This is the first part of our chapter. Next is the magnetic effect of the current. By the way, I'm trying to explain everything and also to make an application for your questions. By the end of the lesson, I'll make, we will solve together some questions, or I'll solve for you some questions in your past papers and give you a homework in your past papers. So, they discovered that there is a magnetic effect of a current, and you know it. Why? Because you studied before the electromagnet, that when a current passes in a coil, it produces magnetic field. Here, we have magnetic effect of a current. If a current carrying a direct current, if a wire carrying a current or direct current is placed over or below a compass needle, the needle deflects, showing the presence of a magnetic field. So, look here. Here we have a paper. This is a paper through which a wire passes, like it moves from downward and passes upward. This is the wire and the paper with iron fillings. Okay? When you tap gently on any end like that here, so you will find that the iron fillings giving you circles or concentric circles in this form. This is the current direction. It is upward. And when you put the compass, and look with me, because if I put the compass like that, look, when I make it in this form, or to have it like that, you will find that it points like that. This is the direction. It points to the north. It points to the north. So, number one, for this figure, you have to know that the magnetic field line, or the circle that represents the magnetic field, it is circles, as we said. The magnetic field should be tangent to it. So you will receive a question that have the compass like that, either in any direction, if it is perpendicular in any direction, this one or these ones are wrong. It should be tangent to the circle. That's why I drew them here tangent, okay? So let's apply this figure by a rule that is invented by Ampere. Who is Ampere? Ampere is a scientist, and he discovered that if you hold the wire with your right hand, where the thumb indicates the current direction, which is upward, you will find that the magnetic field is anti-clockwise. Do you see the direction of his fingers? So it is anti-clockwise, anti-clockwise. So because the clockwise is to the right, so anti-clockwise to the left. I'd like to say something for this circle. Look here to this figure. Okay, when the current is upward, for an easy way to represent it, you will find to the right, do a sign or do an arrow upward. If it is upward, to the right, it is upward. So it makes you, helps you to remember it easy. So now we finished what's meant by the magnetic field in a straight wire carrying a direct current. We'll move to the next page. This is the rule, or this is the page, and as I explained, this is the direction of the current in this photo. Next. Look here, dears. Do you see this graph or this diagram? Dot, now we will use a new concept. Dot means that the current is upward. X represents that the current is downward. Okay? And magnetic field is affected by the distance. So if you are close to the wire, so the magnetic field is strong. As you move away, so the magnetic field becomes less. How can we represent it in a figure? Okay, around the wire, the circles are close to each other, and as I move, do you see this distance increases? Okay, this distance increases, and after that, it becomes bigger and bigger, which means that close to the wire, the magnetic field is stronger, which is represented by close number of magnetic field. Just to remind you that we said before in chapter 14 that talks about the magnetic field, that as the number of lines are close to each other or in a unit area, if we have a certain unit area, something like that, the unit area, if it has large number, so it means that it is a strong magnetic field. Here, as you see, there are two lines, and here there is one line in the same area. So here it is a stronger magnet, while here it is a weaker magnet, which means that its ability to attract more iron fillings or more nails is less. Now we'll look to these figures. What these figures represent. Here you can see that the current is upward, and here the current is downward. Okay? So if I draw this one, let's draw it together at a side. So, like that. I'll draw the three figures. Okay, this is one circle. I'll draw just only one circle around each one and explain what do we mean by it. So, look with me. Since the current is upward here, it means that it is anti-clockwise. And the magnetic field here is downward, so it is clockwise. It is clockwise. Look here, dear. Inside or in between the two wires. What is in between the two wires? Between the two wires, the two magnetic fields are in the same direction, which means there is a repulsion between the two wires, which means that this wire moves in this direction and this wire moves in this direction. It is a repulsion. Here current is upward, here current is upward. As you know, that the direction is drawn in this form. So in between the two wires, the current in opposite, the magnetic field is in opposite direction, so there will be an attraction. Here we have two axes, which means that the magnetic field, the current is downward. When the current is downward, so it is clockwise. This is a clockwise. Look here. As you see, it is in opposite direction, which means there is an attraction. So the conclusion from this figure is that When the magnetic field in between, when the current is in opposite direction in the two wires, so there is a repulsion. When the current in the same direction in two wires, there will be an attraction, and if they are downward, both of them will be an attraction. Now, it is the next page. It is the next page. So, as you see, we studied before this graph because it represents the magnetic field around a bar magnet where it moves from the North Pole to the South Pole, and we draw a direction like that. So, what is this? It is a solenoid or coil. For simplification, it is coil. The coil, it means that there is a coil that passes current. Do you see the direction? This is the direction as it moves in it. So the coil receives a current, So as you see, the magnetic field around the coil is similar to the bar magnet, okay? And you can see it outside the solenoid, very similar to that of a bar magnet, similar to that. But what about inside the turns? Inside the turns that you can see they are parallel lines. They are parallel lines. So parallel lines, they are called a uniform field. So usually, how do you describe a uniform field? Uniform field is a magnetic field that has lines which are parallel to each other. And as you see, here is the north, here is the south. There is no need to know what I'm saying. How do you know the north and the south? So if you use your right hand, so your right hand will show that the direction in it, okay? Next. The direction here is reversed, so it is here like that and here like that. So the current shows this direction. So where is the current like that? So if you have your right hand, do you remember your right hand? If it is like that, and your right hand from the back, okay, so this is the direction of north, and this is the direction of your applied. You will see that these fingers indicate the direction of the current, so this one indicates the North Pole. There is no need to study it by heart, but just I'm trying to explain why this side is north and why this side is south. This is the termination of the direction of the magnetic flux lines. Okay, Ampere right-hand grip rule. Imagine the wire to be grasped or held in the right hand, having the fingers point in the direction of the electric current direction, so the thumb points to the North Pole. Now we are moving to the next part, which is the idea of motor. What's the main idea of motor? The main idea of motor is, this drawing is tried to make it 3D. As you see, you have a magnetic field from north to south. You have the positive, so the current direction like that, and for the wire inside the magnet, it is downward like that. So you will find that there is a magnetic field, there is a current, so there will be a motion. Do you look? This hand is the left hand. And the man who invented a rule for the left hand, his name is Fleming. So he said that Fleming left hand rule. What is Fleming left hand rule? Fleming left hand rule states that let your middle finger or the second finger points to the direction of the current where it is downward. Okay? Then your first finger or the forefinger, F-O-R-E, forefinger points to the direction of the magnetic field, you will find that the wire will move in a direction perpendicular to the direction of the current and the field, which is this direction, which means if you imagine this one, when you apply it using your left hand, it means it comes out of the figure. It comes out of the figure or out of the page you are working on it. This side explains how does it come. There is a magnetic field in between the magnet. In case of presence, no current. And this is the current only, where the current is downward, as you see. So it has a magnetic field, as you know. When the current is downward, it is clockwise. Here it is clockwise. When they are combined together, this one and this one, it produces for you this figure. What is this figure? There is a circle, one circle around it, this circle around it like that, and this is a direction like that. So there will be a repulsion between the magnet field and the wire field. So the magnet field from left to right, the the magnetic field due to the current in the wire is in the opposite direction, which means we say it is weak repulsion or attraction. From the side, the direction here, like this direction, so there will be a stronger repulsion or large repulsion between them, which means also that the wire will move down. Okay? So now we explained this idea. This is another shape that shows you how you can use your left hand rule to find the direction. It is 3D, so it helps you to understand it. Now we are going to say some notes. If there is no force on a wire that plays parallel to the magnetic field, which means, do you see, this wire is perpendicular to the magnetic field. But if the magnetic field like that and the wire like that, this one is not the magnetic field. No, it is the wire that carries the current. Here it is the wire carries the current. So these two magnetic fields are parallel to each other. So no motion or no force. Again, the wire is parallel to the magnetic field, so no force. The force on the wire increases when the current increases. Yes, because if the current increases, so number of circles or number of concentric circles around the wire becomes have larger number. So it will increase. B, the magnetic field between the poles and the magnet increases. So if the magnetic field, this one and this one, increases, it means that you have a strong repulsion act on the wire, so it moves with a bigger force. Now we will study the electric motor. Electric motor is a device that is used to convert electric energy into kinetic energy. The simpler word, like the fan. When the current passes in the fan, so the fan rotates. So we have a figure as you see. So it is a current here. The current you have positive to the left, negative to the right. And I'll try to draw it step by step to understand every single point in it. It is north. This one is south. There is a coil. Instead of the wire, do you see, this is a straight wire. We will bend it. So we will have it in this form. It is one straight wire, but we bend it in this form. Okay, we'll make this side north. We'll make it in red. And this part of the coil, we will color it red just for illustration to understand it easier. And the other side, which facing the south, we will color it by blue. So it is the same drawing here north and south, and these are the sides. Next, the end of the coil will be, if you have a ring, and when you split this ring, and put an insulator in this part, a small part, so it will be like that. We draw it as 2Ds, So we can say that this is a split ring. Okay? Where this split ring touch two brushes. This brush, and I'll draw the second brush like that. And the outside circuit, it is the same as you see. So now I simplified this figure, or draw it step by step. What is this? It is called brush or graphite brush. It is graphite brush. So what happens? They say that the magnetic field of the magnet passes like that from north to the south. Okay? The magnet here, the coil here, is exposed. These sides are exposed to the magnetic field, and they are perpendicular to each other. So they are affected by a force. This force causes the object to rotate. So if I draw a line like that, like this is an axis, and if we apply the direction of the current, this is a positive, so it will pass like that through the brush, through the split ring. Then here it will be like that, and it will be like that. If you apply a Fleming left-hand rule to the side facing the south, we will face it. So the magnetic field, as you know, it is this direction. And this is the current, direction of current in the coil. So when you apply it using Fleming left-hand rule, you will find this one to move upward. So from the up point, I draw an up line. So this one will move down, which means that it will rotate. If you look to that, it rotates in anti-clockwise moment. So when the coil in shape B, so we explained when it is in A position. In B position, after 90 degrees, usually we consider the circle as 4 quarters. Circle is 4 quarters. Each one is 90 degrees. So if I start like that, 0, 90, 180, 270, and then 360, which corresponds to 0 on, also, or return to the first part. So after 90 degrees, what happens? Do you see that the coil becomes perpendicular to the magnetic field? Or in other words, to simplify the concept, that the magnetic field passes through space between the two wires. So the motion or the speed as the motor rotates from 0 to 90 like that, there is an angle. Do you see? There is an angle changes. As the angle changes till reaches 90, so its speed slows down because the effect of the magnetic field decreases. At this point, what happens? This split ring will be perpendicular in an opposite direction, so I can draw it like that. So it will be the red one will be like that, and the blue one will be like that. Okay, after 90 degrees. Here is the separation, so the effect of the magnetic field is the least. At this moment, it starts to continue rotation. When it continues rotation, so there is the force again, so its speed increases more than before. So if it starts with a speed, suppose any number you want to say, 0.1, so now it will be 0.15 or any number greater than 0.1. Now it returns again after 180. Do you see? This is the blue side which facing the north. After 180 degree, the red one facing the south, okay? So, and it continue rotation. Let's say or simplify what we said more. It comes in the exam like that. Explain the principle of operation. Explain how does an electric motor work. Or sometimes it is said DC motor. Why it is DC motor? Because it uses direct current. You will explain it as follows. When the electric current passes through the wire, it produces magnetic field around the wire. Next, the magnet field interacts, it is important to mention interacts with the wire field, causing repulsion at one side and attraction at the other side. Okay, so when he mentions how does it work, you will mention these two steps. The electric current passes through the wire and produces a magnetic field around the wire. The magnet field interacts with the wire field, causing repulsion at one side and attraction at one side, so the coil rotates. Okay. Next, how can you increase the speed of rotation or the rate at which the motor rate? Okay, we have three components here. We can increase them. Number one, the current. If it is one cell, make it 2 cells, 3 cells, or whatever the value. By values, instead of 2 volts, 4 volts, 6 volts, and whatever. If you have a variable resistor and a big battery, you can change the speed of it. So by increasing the current or the voltage, you can say any one of them, it means the motor speeds up. Second, if you increase the magnetic field strength, if you have a stronger magnet, it will give more number of magnetic field lines, which means the speed of the motor increases. The third one, here, all what we explained, it is one turn. What if they are 2, 3, 4, 100, or whatever? It increases by increasing the number of turns of the coil, so the speed of the motor increases. Do you know the fan that you have at your home, which is used in many, that you have multi-use for the electric motor, but I'm talking about the fan you have at your home? Okay, when you change the speed, what happens? Actually, you are controlling the number of turns, or you can control either the value of the current using a variable resistor. How can you reverse the direction of motion of the motor? Okay, you can reverse the direction of the current. If this one is a positive and this one is a negative, you can reverse it to have it as negative and positive. So as you reverse it using the two-way switch, you can reverse the direction of the direction of motion, also by reversing the direction of the magnetic field. Dears, we reached the end of the chapter, and we have a lot of questions about this chapter. In another video, I'll solve with you some questions about it. But that is the end for today, and this is the explanation of chapter 19. Study it well by today and tomorrow for maximum, and on Sunday you will receive more and more videos about